So far, the two functions that we've written, they are taking numeric arguments, grams and length, and doing a computation. But the arguments can be any data type. They could be characters, Boolean, integers. They can be any data type, and also they can be any data structure. They could be tibbles, they could be data frames, they could be vectors, and so on. To see an example, let's say what we wanted to do was take an airline and determine of all the flights for that airline in the flights dataset, what was the longest delay that that airline suffered. Okay, and so let's write a function to do that calculation. So we'll say get longest departure delay and assignment operator function, and this will take two arguments. One will be the input data set, which will be flights, and the other would be the code of the airline for which we want to determine the longest delay. Then we have our curly braces, and really it'll be just one statement. Longest delay would be, we take the flights data set and we pipe it to filter, and we want carrier because the column that contains the airline codes is called carrier, is equal to the airline code argument provided to the function. And then we pass this, we pipe this to something that would determine the longest delay. So I could use arrange to arrange all the rows, but I don't really need to arrange all the rows since I just want the longest delay. So the most efficient thing here would be slice max, and the column we want is depth delay, and we want the biggest value, so just n equals 1, and this statement will produce the row of the flights dataset which would have the longest delay suffered by the airline specified by the airline code. And we just want to return as output, return as a result, the value of the departure delay. And so we can simply use the dollar syntax to select the depth delay column and return it. So now let's see what is the longest departure delay suffered by, let's say, delta. And so I will call my get longest depth delay function, and I don't need to give it the flights dataset as the input data argument because that's the default value. I just need to provide it with the airline code, and the airline code will be DL for delta. And when I run this function, I get the result, which is 960 minutes. So the longest delay a Delta flight suffered in 2013 was 960 minutes. Now, we have seen that our functions can take multiple inputs, multiple arguments. What if we wanted to provide multiple outputs? So what if in addition to the departure delay, we also wanted to know what was the origin airport? Where did the flight leave from that had the longest departure delay for whichever airline code we are talking about? So let's try and do that. Let's modify this function and try and return not just the departure delay, but also the origin airport. And when we do this, we get an error. And the error we get is that multi-argument returns are not permitted. So when we are returning, we cannot return multiple things. We can only return one thing. But it is still desirable, as in this situation and many others, where you want to return multiple items. And this can be accomplished by using a new data structure that we haven't discussed yet. This data structure is known as a list. And a list is a collection of name value pairs. So you would have name1, value1, name2, value2, and so on. In other words, a list is like a phone book or a dictionary. So for example, we could have something like a person's name and their phone number, and so on. So a list is a way of representing a dictionary or name value pairs. So let's do an example. I could create a list, and you basically, in the arguments to the function list, you provide the name value pairs. So for example, I could say Adam equals 1, 2, 3, 4, 5, 6, 7, and Brad equals whatever. And then I can look at what X is. And in this case, you see that there is a name. Another word for it is a key. And the first key is Adam, and its value is this phone number. And the second key is Brad, and its value is this number. And you can access the values, so you can index the list with the names or with the keys. So unlike vectors, where we index by the position or numbers in the square brackets, in lists you index with the names or the keys using the dollar operator. And so when I run this code, it returns the value associated with this particular key. Now, one really important characteristic of lists that set them apart from vectors is that in a vector, all the elements have to have the same data type. That's known as an atomic vector. So if you have a numeric vector, then all the elements have to be numeric. But lists allow you to mix and match different types of data. So I could have the second key not be numeric and have characters. I could have the third key be logical. I can even mix different data structures. So these three that I have here are scalars, they're single values. But I could also include a character vector as a value. And when I run this, it runs without problem, and I can then access the different key name value or key value pairs. And in this case, I could look at David, and it's a vector. Of course, I could even put in instead of a vector, I could put a data frame. And let's see, I could have a column. Another column. And here we're mixing in one list a numeric scalar, a character string, which is a scalar, a logical scalar, and a data frame. So lists are an important way of combining, mixing different types of data types and data structures under one variable name. So this ability of lists to mix and match different types of data, different data structures under one variable name, make them a great tool to return multiple items as part of the output of a function. So now I wanted to return the departure delay and also the origin airport of the flight that had the longest delay for a given airline. And so here in return, I can simply construct a list, and I can say one key or name is delay, and the value is going to be the departure delay of the flight that we have determined had the longest delay for that particular airline. And then we can add another key for the origin airport with the value of origin, and there's my list function, and I have to close the parentheses for the return function. And now I could take the output of this function, get longest depth delay, and perhaps assign it to a variable longest DL, because I'm looking at delta. And then I can look at the values of the delay, the origin. And there you go. We have been able to return multiple things by combining them in a list. And it's important to remember, you can combine, here we are combining two different data types, a numeric, which is the delay, and a character string, and returning them together. And we could return arbitrary things by combining them in lists. And you can even return plots or plot objects. Let's see how you could do that. So let's write a function that takes an airport code and returns a plot, plotting the average number of flights departing in each hour during the day. So we will call our function get plot, because we are returning a plot. Get plot average num departures per hour. Okay, this is a function. And so far, dealing with the flights data set, we've been passing the flights data set as an argument, and we made it the default argument. The fact of the matter is the functions that we are writing right now will only work with the flights dataset. And so it's perhaps not necessary to have the flights dataset as an input argument, because our function would simply not work. We can't change it. So it's actually not a variable thing that will change from use to use of the function, but it's a fixed thing. So we can leave out the flights dataset as an argument, and we will just have the airline code here as the argument. Now, when you're writing functions that use packages, so in this case, we are going to rely on the NYC flights package. It's good practice to actually load the package inside the function, because if it had not been loaded before and your function relies on it, you will get an error. Now, we could simply do load the library saying library and the name of the library. However, you've noticed how when we load libraries, we get messages, sometimes warnings about functions being masked and so on. So there is a quiet way of loading libraries, and that's called require. And we should use require to load the library. It's silent. If the library is already loaded, it will do nothing. And if the library has not previously been loaded, the library will get loaded, but all warning messages will be suppressed, and so that the flow of the function is not interrupted. So now what we want to do is we want to take the flights dataset and construct a plot object. And so let's see, we will say plot average number depth per hour, and we will take the flights data set, the flights table, and pipe it to the filter verb. And that's because we are only interested in flights from the carrier matching this airline code. So we'll filter for this airline code, and then we're going to take this. So this will be all the flights in 2013 between all origins and destinations flown by whatever this airline code is. Now, what we would like to know is what is the average number of departures per hour, and that means we want to summarize and to calculate the average number of flights. But before doing so, we have to group by hour, so that we have each hour is a group, and so that when we summarize whatever function we choose for the summary, it will act over all the rows, all the flights belonging to a particular hour. So let's group by hour, and then we would like to summarize, and our summary is going to be the average. That'll be the column name, the average number of flights. So how can I calculate the average number of flights? Well, the n function gives me the number of rows in each group. So since I've grouped by hour, in this case, when I call summarize and with the function n, it will give me all the number of rows, that is the number of flights in each hour. And then we can just divide by how many times a given hour occurs in the year. For example, how many times does the hour 5 occur in the year? And that is 365. Each hour occurs once each day, So each hour occurs 365 times in the year. And then we can pipe this to ggplot because we want to produce a plot. And since we are using the pipe, we don't need to give the first argument, which is the data. We just need the aesthetics, and the x-axis is going to be the hour, and the y-axis is going to be the average number of flights in that hour. And now, what is a good way to plot this? Probably a line plot using geom_line would be a good way to plot this. And then we can go ahead and just return this plot object. So flights is a tibble. We're piping that to filter. Filter produces another tibble. We're piping that to group by, which produces a tibble, which we're piping to summarize. Summarize produces a tibble, which we pipe to ggplot, and ggplot will produce what's known as a plot object, which we have assigned to this variable, and we're returning it. And now we can call this function and assign this to another plot object. So average number depth per hour for delta. So we'll say get average get plot average num departures per hour, and we'll give the airline code as delta. Okay, and when I run this tibble, no plot is produced since the plot object has been assigned to a variable. So to actually produce the plot, I call the plot object, and here I have the average number of departures per hour for delta, and we can see that the average number of departures is very high in the morning and then goes down during the day, but then picks up around 3 p.m., peaking around 7 p.m. and then goes down, which sort of makes sense. Now, the cool thing about these plot objects is that we can still add layers. So you could create a general plot inside a function, but then you can customize it outside by adding layers. So we could add here a title, for instance, average number of departures for delta.